Hello friends, have a good day. We'll continue problem on clutches. Today we'll solve a problem on multiplate clutch. So let us take an example. A multiplate clutch is composed of 5 steel and 4 bronze discs. The clutch is required to transmit a maximum torque of 240 Newton meter. Assume a factor of safety of 2.5 for a slippage and full engine torque. If P intensity of pressure P equal to 0.35 megapascal and coefficient of friction F equal to 0.25, then calculate diameters of friction lining. Now they have provided number of disc on driver and number of disc on driven. Let's go for NS. Now number of steel discs are 5 here. Number of bronze discs are 4. Okay, and torque it is to be transmitted is what? Now we need to calculate the TF. That means what is the frictional torque is required to transmit this much of torque. Okay, let us need to calculate TF. Now T they have given. It is what? 240 Newton meter. Okay. Now this service factor or engagement factor or a factor of safety beta is given. Okay, so beta is how much? It is a 2.5, and pressure P is 0.35 megapascal and the coefficient of friction F is 0.25. So now let us calculate first what is the total frictional torque required to transmit maximum torque of 240 Newton meter. Okay. Now we will calculate first the frictional torque. So you refer design data and book, notify equation number 13.9G. This is what 13.9G. Now TF equal to beta. This is what a service factor into design torque. Now beta is how much? It is a 2.5. Design torque is 240 Newton meter. Let us convert it in Newton mm. So approximately you are going to get 6 into 10 to the power 5 Newton mm. Now you need to calculate dimensions of the discs for this torque. Now we know that the torque transmitted by n dash pairs of friction surfaces. Okay. Now torque transmitted by n dash pairs of friction surfaces. You refer equation number 13.9f from design data handbook. It is what t equal to 1 by 2 mu n dash FAW into D EMW. Okay. Now FAW, as they are not specified, you need to substitute in terms of a relation. Now, as you have not specified what type of case or what type of theory you need to consider, so now let us go for the wear theory. That is what uniform wear theory. Okay? We'll go for uniform wear theory. Now T is our torque 1 by 2 mu and dash. Now FAW is what? 1 by 2 into pi into P max into di into d naught minus di into dmw. Okay. Now this equation is related to the axial force in uniform wear condition. Okay. Now let us substitute dmw equal to do plus di divided by 2 from data and book. Now let us rewrite here t equal to 1 by 4 mu n dash pi p max di do square minus di square. Okay. Now let us calculate n dash pair of friction surfaces. So n dash equal to what? Ns plus nb minus 1. Okay. So ns is 5 plus 4 minus 1. We are going to get number of pair of friction surfaces, n dash equal to 8 here. Now if you look at this relation, T, di and d naught are unknown here. Di and d naught are unknown. Let us substitute first values. 1 by 4, mu is 0.25, n dash is 8, pi 0.35 is our intensity of pressure. Okay. Now di is unknown, d naught square minus di square. Now d naught is also unknown here. D naught is also unknown. Okay, now t equal to, if you simplify equation, you are going to get a t equal to 0.2749 into do square minus di square into di. Equate this equation with the frictional torque required. Now is what 2.18 into 10 to the power of 6. Sorry. So you need to check this value as well as this value. Okay. So I think let us scrap here. Now 6 into 10 to the power of 5 equal to 1 by 4 into pi into 0.35 pressure into coefficient of friction into di do square minus di square. Now to solve this equation, two parameters are unknown here. One is what do and another one is di. Now if you look at the relations to get the maximum torque T max, the diameters of ratio d naught by di should be less than or equal to 0.577. Okay. Less than or equal to 0.577. Okay. So if we consider the constants, that is what space limitations with intensity of pressure P and coefficient of friction as F, and if you derive the torque equation, and if you gone for a differentiation of this torque equation with respect to the parameters, that is what the dimensions. Okay, if we equate it, dt by dy equal to 0, we are going to get some value. That value is what the ratio of outer diameter to the inner diameter. Sorry, inner diameter to the outer diameter. Okay. Now this has to be di to d naught, di to d naught. It should be less than or equal to 577. Okay. Now for safer side, so let us assume, so di equal to 0.5 times of d naught. Okay. Di equal to 0.5 times of d naught. Okay. And if you substitute back in this equation, if you calculate or if you compute the values, you are going to get a d naught, that is what outer diameter, approximately 180 mm, and inner diameter is what 90 mm. 90 mm. Okay. Thank you.